Bismillahirrahmanirrahim. Assalamu alaikum. I am Kashiful Khair from BS Chemistry Department and my ID is 018. Today I am going to present the topic of geothermal energy. So firstly have a look at the content. In this presentation, firstly I am going to tell you the introduction of geothermal energy. After that, geothermal reservoirs, extraction and the uses of geothermal energy, electricity generation from geothermal energy, sustainable energy, and at last pros and cons of geothermal energy. So let's start with the introduction of geothermal energy. The word geothermal comes from Greek word geo means earth and therm from heat. Geothermal energy is heat energy that is generated deep within the earth's interior by the decay of radioactive element. Geothermal energy is abundant, but like solar energy, it is widely dispersed. It is a renewable source of energy. The next, how geothermal energy is generated. The sources of geothermal energy lie 6,500 km beneath the Earth's surface, which we called as core. Core contains the hot magma. Surrounding the core is the mantle, and the outer layer is called crust. The crust is not solid shell and is broken down into layers. Magma comes close to Earth's surface near the edges of these plates. The temperature of magma is between 900 degrees Celsius to 1000 degrees Celsius, and it will heat the rock and groundwater that comes in contact with that magma. The temperature of the rock and water get hotter and hotter as we go deeper underground. Next are the geothermal reservoirs. Basically, a reservoir is a large natural artificial lake which is used as a source of water supply. Reservoir can be suspected in the areas where we find geysers, volcanoes, boiling mud pot, and hot springs. Basically, geysers are the hot spring in which water intermittently boils, then sending to all water columns and then stream into the air. Volcano is a rupture in the crust of planetary mass objects such as Earth that allows hot lava, volcanic ash, and gases to escape from magma below the surface. They are often found where tectonic plates are diverging or converging, and most are found underwater. Then the next is boiling mud pot. Basically, it is a natural double boiler. Surface water collects in a shallow, impermeable depression that has no direct contact with underground. It is impermeable due to lining of the clay. It is basically a pool of acidic hot spring with limited water. It usually takes the form of a pool of bubbling mud. Reservoir may contain hot water, steam, or both. Geothermal wells, which are basically similar to oil wells, can be drilled into these reservoirs to release the hot water or steam. And the hot water is used to heat our buildings, houses, etc. And the steam is used to generate electricity. Hot rock can also be exploited to obtain steam. To do so, cold water is injected into the well drilled into the hot rock. The water returns to the surface of stream, which can then be used to generate electricity. The rising hot water and steam is then trapped in permeable and porous rocks to form a geothermal reservoir. Reservoirs are generated by testing the soil and by analyzing underground temperature. The next topic is the uses of geothermal energy. There are basically two uses of geothermal energy, direct and indirect. We use direct geothermal energy for district heating system and for heat pumps, and indirect is for producing electricity. So firstly, we will see the direct use of geothermal energy. First, there is district heating system. We use hot water from hot springs or reservoir near the surface. This water is piped directly into homes and industries for heat. The next is the heat pump. Basically, heat pump is a device that takes heat from one source and moves it to another location through electrical or mechanical means. Heat pumps utilize constant temperature of upper 10 feet of the Earth's surface, and they are similar to ordinary heat pumps, but they rely on more stable source than they are. Next is the electricity generation. Basically, steam is used to generate electricity. At the first, hot water is pumped from deep underground through a well under high pressure. So when the pressure of water reaches the surface, pressure is dropped, which causes the water to turn into steam. The steam spins a turbine which is are connected to a generator that produces electricity. The excess steam cool off in a cooling tower and condensed back to water. This cooled water is pumped back into the earth to begin the process again. Basically, there are four types of geothermal power plant: flash steam power plant, dry steam power plant, binary power plant, and hybrid power plant. Firstly, we will see what is flashed steam power plant. Flashed steam power plant uses hot water above 182 degrees Celsius from geothermal reservoir. Its working is very simple. The boiling point of water flood increases as the pressure is increased. So the hot water is pumped into flash tank. The pressure of flash tank is lower than the flood. So the water converted to steam. After that, steam spins a turbine, which is then converted to a generator that will produce electricity. Surplus water or excess water from flash plant will be re-injected into the ground to restart the process again and again. This is a picture of flash steam plant. The next is dry steam power plant. Usually geysers are the main reservoir of dry steam power plants. Let's have a look at its working. Basically, dry steam power plants directly use geothermal steam of 150 degrees Celsius as reservoir which uses steam with small quantity of water use this power plant. A rock catcher is used to protect turbine from rock coming along with steam. Then the steam is fed directly into a turbine with a secondary heat exchanger. And after that, the turbine run on generator and generator will produce electricity. This process only requires removal of rock fragment to entering its turbines. The next is binary power plant. Binary power plant uses geothermal water, and in this geothermal water is passed through a heat exchange where the heat is transferred to a secondary liquid. Liquid having lower boiling points are used such as isobutane, isopentane, etc. So, and the vapor of secondary liquid is then used to turn turbine, and turbine is then used to turn generator, and generator then will produce electricity. Also, excess amount of water is re-injected through the injected well to restart the process. Binary power plant has higher capital costs, needs high efficiency equipments, water returned directly to the reservoirs. This is a picture of binary plant system. The fourth type is hybrid power plant. It uses both boiling water and steam to produce electricity. Steam is directly used as used in flash steam plant, and energy of hot water is used through secondary liquid as used in the binary plant. The next is sustainable energy. Geothermal plant is considered to be sustainable because of small heat extraction as compared to Earth's heat content. Unlike solar and wind energy, geothermal energy is always available. It is relatively less expensive, like saving from direct use can be much as 80% over fossil fuels. Uses much smaller amount of water as compared to the other power plant. Next are the pros and cons of geothermal energy. Let's have a look at the pros. Geothermal energy is pollution free, does not contribute to greenhouse effects. Power stations are compact, no fuel is needed, generate energy and then use it. Once we build it, the energy is almost free in geothermal power plants. Next are the cons of geothermal energy. Geothermal energy has high initial capital cost, suited to a particular region, extremely high temperature required, distribution cost effects, and can cause surface instability. The future of geothermal energy. The future of geothermal energy is uncertain. Many geothermal fields occur in rugged, inaccessible terrain. Many are located in scenic areas such as Yellowstone National Park and cannot be developed. Most steam deposits contain hydrogen sulfide. Salt dissolved in the water released with steam from reservoir can corrode pipes and other fixtures, and if not prevented from reaching streams or rivers can cause severe ecological damage. Despite these problems, the use of geothermal energy is likely to increase in areas where it can be exploited as oil becomes scarce and more expensive. Next is the geothermal energy in Pakistan. Various geothermal indices are present in northern areas, Chagai area, Karachi and Hyderabad. Hot springs with high brine temperature are present in the northern western Balochistan. So thank you. That's all from my side.